invite our first speaker, Shadman Nahid, for his presentation.
Good evening, everyone. Today I'm going to present my research work. The title of my presentation is Land Use and Land Cover Dynamics and Simulation of Future Urban Growth using the CANN approach in Delhi-NCR. This is the outline of my presentation. I will covering it all in my subsequent slides. Coming to the introduction parts, as we know that the urbanization exerts a pressure on various environmental components such as air, water, soil quality, biodiversity, land use, land cover changes, and the climate changes. So how these actually, ma'am, it's showing some issue with give me a minute. Actually, what happened? Actually, what happened? My screen. Oh, yes, now. Sorry for disturbance. Coming to the introduction part, as we know that the urbanization play a vital role and it exerts a pressure on the air, water, soil, and biodiversity, as well as the land use, land cover, and local climate, leading to the environmental degradation. So land use, land cover changes alter the ecosystem processes, biodiversity, energy balance, and human well-being. So behind these changes, there are a lot of hidden drivers, including the population growth, economic development, industrialization, policy shift, and the climate changes, particularly in our Indian cities like Delhi, Mumbai, Chennai, Hyderabad, and Kolkata, facing the rapid urban growth, environmental degradation, and ecosystem decline. So this is particularly I'm working on the Delhi and its surrounding area. So in Delhi region, the expansion of the built up area has reduced forest agriculture and causing the water stress, climate shift, and the higher land surface temperature. So to address all these issues, we are using nowadays the very advanced technologies, the remote sensing and geospatial models, CNN, and these are the models which are widely used and to forecast the land use, land cover changes. So particularly our study, the study is assess the land use, land cover patterns, predict future trends using the CNN, and the evaluate urban sprawl within with the Shadman Entropy Index. This is the map of the study area, Delhi and its surrounding, having the latitude and longitude. The red color is showing the elevation, in which the red color showing the high elevation, and the green one is showing the low elevation. Coming to the next part. Actually, coming to the, this is the map. These are the data sets I have used in our study area. We have taken the Sentinel and Landsat satellite data for mapping of the land use, land cover from the Earth Explorer, and also we have taken the other variables like distance from water bodies, forest, all these also taken from the Earth Explorer sites, and the we have taken the road network data from the OpenStreetMaps, and the elevation, slope, and aspects data is taken from the Earth Explorer from the SRTM. Next, ma'am. Yeah. So this is the flow chart of my methodology part, in which I have taken the land satellite data from the Landsat and Sentinel for the image processing and the LULC classification with the help of the supervised classification method. And further, we have done the LULC change detection for the subsequent years. And also we have validated the LULC classification using the two validation method. Like first one is the ground truthing and second is the accuracy assessment method. And also we want to see the how urban sprawl changes over the time. So we have used the Shannon entropy methods. Again, we have ma'am, actually we have also taken the is 7 variables: elevation, slope, aspects, distance from road, distance from the water body, distance from the forest. All these variable we will used as an input for the model for the land use land cover prediction models. So we have taken as an input LULC 2013 and 2020 for to see the transition calculation for the prediction for the further futures for the years of 2033. Next, ma'am. These are the results of my study. Coming to the results part, Figure 3 represent the land use, land cover, spatiotemporal distribution of Delhi for the subsequent year. Coming to the first is the LULC maps for the 2003, 13 and 2023. In this, these are ma'am, can you see this? Yeah, actually, these are the classes, LULC classes represent by the different codes colors, in which the red color showing the built up area, whereas the yellow color showing through the agriculture, and the blue color showing the water body, and respectively. So in this plots, you can see the result, the unequal shift in the pattern of the land use land cover from the 2003 to 2023, and the increase in the built up area, particularly in the core region, and also the decrease in the agriculture and forest area. You can also see the water bodies areas also continuously shrinking. And these LULC maps having the kappa values for the 2003 is 0.77, and for the 13 0.82, and the for the 2023 is 0.81. So next, ma'am. So these are the area statistics of LULC classes, in which we can see the all these LULC classes having in terms of kilometer and in terms of percentage, where you can see the prominent increase in built up area of from the that particular area to overall the growth is 10%, whereas the forest area decreased by around 1% over the 20 years. Over the whereas the scrub and open land consistently decrease 0.7% and 0.29, whereas the agriculture land has decreased from the around 10% over the 2 decades. Ma'am, next. Yeah. So these are the change detection map. Change detection map is particularly see the statistics between the from to two changes in the LULC. You can see these core region, particularly in the core region, there is no change particularly, but you can see the in the periphery region, there is a transition between the one classes into the another. The red one is showing the how agricultural land is converted into the built up area, whereas all these classes, you can see the how the conversion is happened over the 20 years. And whereas the scrubland and agriculture change into the built up, in particularly the western, northern and the southern part of the Delhi, whereas the prominent growth of the built up area in the north, east, western and southern part of the Delhi, the primary transformation has been an increase in built up area at the expense of agriculture, open land and the scrubland. Ma'am, next.
Sorry to interrupt. You only have a minute left now, so would you mind wrapping it up?
Yes, ma'am, please. Forward. These are the transition statistics of LULC. You can particularly see the built up area has changed, but mainly in the from 2 decades, from 78% rather than the other area. Ma'am, you can next come to the next slides. uh, these are the accuracy assessments for the LULC prediction. You can see the kappa, these are the user accuracy, producer and overall accuracy, and these are the kappa values. The mainly the kappa values mean the accuracy is the validation of the LULC classes for the ground using the Google Earth images, and also from the ground truthing method using the GPS. And yes, ma'am. Next, coming to the end, these are the ground validation. We have done the Grameen 10 monitoring. You can see all these classes showing red color is showing the red built up area, where the, in the ground also these are the road areas, and also yellow is showing the agriculture, and on the ground these are the agriculture area. Ma'am, coming to the next, these are the variables we used for the prediction of LUL's future prediction. The dam slope aspects and distance from forest water. Ma'am, next. So uh, yeah, these are the projected LULCs suggest the shift from agricultural land to the built up area from by the 28%, and the forest area expected to the around very reduction around nearby less than 1%, and agriculture also by the decrease from the 4%. And the projected LULC for the LULC suggest a minor loss likely due to the natural process such as anthropogenic activities. And the project, yes ma'am, next. And these are the order of the influencing of the LULC pattern, how which variable is the most influenceable for the changing of the LULC. The distance from the built up is showing the high influence, because they have the high tendency to change one class into the another. And the list is the DEM. Next. And these are the Shannon entropy index, in which we see the entropy index shows the urban sprawl over the time. The urban sprawl is mainly in the zone 2, then the zone 1. The circular one is showing the zone 1 having the areas within the 30 kilometer, and the area having the outer side is. So urban sprawl one has occurred in the more in the periphery than the core areas. So mainly because in the core area there has no space for the further expansion, where the in the surrounding area we can also expand the urban sprawl vertically rather than the horizontally. Yes, ma'am. And this study highlights the rapid urbanization expansion. Delhi-NCR built up area is increased by 10% at the cost of forest, agriculture, open land, where the urban growth is concentrated in the peripheral, in the city core, intensifying the regional disparity. And the simulation reflect that the 28% of rise in built up, indicating the accelerated urban sprawl. The conversion of agriculture and forest into the urban, that shows the serious ecological balance and resource sustainability. And also the urban growth make it difficult to the local government to provide a necessary infrastructure services, leading to the lower quality of life, which raising the sustainable development goal like the sustainable cities and communities. This finding emphasize the urgent need for adaptive data-driven urban planning to manage future land use and dynamics. And these insights of the study inform the policy revisions and drafting of new master plan for sustainable growth in Delhi and its surrounding. Thank you.
All right, thank you so much. I would now like to ask our chair and co-chairs to give any feedback or comments if you've got.
Yeah, okay. So first of all, I would like to say thank you to the presenter and to the organizer. So this is really a good work. I have a couple of comments or small questions. So you have mentioned several models like, but you preferred only ANN model. So can I ask what is the reason behind this among all the other models like random forest, or you have several others, but you preferred this one? And secondly, in addition to that, you selected the region to be Delhi, although there are several other regions. So what is the reason behind choosing this? And the time period you selected is from
Thank you
2003 to 2023. So why you choose this temporal resolution also? So yeah, so and what is your main finding that you think that you wanted to mention here? Just a challenging finding that you have, because I have seen several work. So, and the last question would be, if you are noting down, can you apply this model to other regions also, or you think that this is only applicable, your findings are only suitable for Delhi region? So yeah.
Thank you, sir. Thank you for asking such a beautiful, wonderful question. First, I would like to answer your first question, why I have chosen only CNN, right? So you told me that there's a lot of model, random forest and other. Yeah, you're right. But for the urbanization purpose, actually, for example, the CNN, the cellular automata, and the ANN is the artificial neural network. It is related to machine learning, right? So CNN is the grid based model where the is related to the tendency of the conversion of because it works on the grid basis. Okay, so what are the tendency? For example, any area like urban area near the urban, so what are the tendency for the conversion of one class, one urban area into the forest and these? So it shows the transition matrix between the conversion of one cell into the another. I think it these method is more reliable or more for example, like more precision rather than the other model, because in different other model I have tried the random forest. The random forest is particularly applied for the other purpose like ecological aspects, and we are looking for the urban expansion aspects. I think it's more because this we CNN give this partial dimension, whereas the NNN give the transition probability, like probability of land use, land cover with the time. And second question is your why I have chosen 2003 to 2023, not other. Actually, according to Landsat data, there's a very less data availability in 2003 from our, for the particularly in our region, for the Delhi and its surrounding. A very few Landsats tiles are available, which are cloud free. So, and the LULC changes can seen not in the gap of 1 or 2 years. You can see the changes in the decadal terms. So that's why I have taken these two decades period. And third is your question, sir. Can you repeat it again, if you don't mind? Sir, unable.
Okay, so
Yeah.
I asked about the third one is why you choose Delhi,
Okay, actually,
yeah, as your study area.
yes, sir. Actually, as we know, Delhi is the most populous and polluted city, and the major concern because most of the people are from the rural areas coming to the metropolitan city for the good infrastructure, good education, good livelihoods. So they are coming to the more for the job, coming to the center of the Delhi. That's what I have taken Delhi, because this is also nearby my place. So it's
So just in addition to this one, I have seen
yeah,
several papers which are already using this
yeah,
region.
yes,
So what is then the difference among your study? Because there are already published work.
yeah, but
They are looking at
okay,
LULC
okay,
changes using the same technique. Even you mentioned that this ANN model that you preferred is a grid-based model, and their other models are used for ecology purpose or something. But I have seen people are using all those models, and then they look at their results, and then they say that because this model is giving better the results
yeah.
for our study, and that's why we prefer this. But you do not do any analysis assessment and you simply so what you said that you prefer this one because this is grid based, and the others you mentioned that they are not grid based.
No, sir. Actually, yes, sir. Cellular automata is mainly the grid-based model. They are looking for the gridded wise, they are looking for the tendency of changes of one cell into conversion of one cell into the another. For example, if in the grid wise, like pixel wise, one pixel comes under the urban area, how what are the probability of conversion of these grid into the next conversion of the next urban area in the future. So in
So
that manner,
have you,
I'm just telling you.
Both
yeah,
Nahid and Dr. Doga, we
yeah.
will have to move on to next presentation now.